Hello everybody and welcome back to my channel. So in the series of must do question from Geeks for Geeks, the next question that we are going to see is the spirally traversing a matrix. So before starting with the video, to all the people who like my video, they see my video but they do not subscribe to my channel, so please don't do that and just subscribe to the channel. Also, if you want short notes for whatever I upload on my channel, you can follow me on my Instagram. I upload short notes over there. And you can find all the codes that I write on my channel on my GitHub handle, so you can go and access. I'll leave the links in the description box. So let's start with this question. So what this question says is that we have to print the matrix spirally. So what over here means this means is that when we print the matrix, so first we have to print it in this way. So first this, then we go over here and we end over here at 24. So the output that will come for this matrix will be this. So now let's see how we can do this. Now see, over here what we are doing is, first we are going towards the right, then we are going downwards, then we are going towards the left, and then we are going upwards. Again, then we go towards the right, then we go downwards, then we go towards the left, and then we go upwards, and so on. So what we say is that every time we have to print a rectangle. So first we are going to print this, then we print the inner one, and then we go so on and so forth towards the inside. So now you know that when we see a particular pattern being followed again and again by any question, so what we do is we can the very basic thing that comes to our mind is a recursive approach, that we can handle one rectangle in one recursive function, and then we can call this function again and again. So what we can do over here is that a recursive function is going to handle one rectangle, and at the end we are going to call for printing the inner rectangle and so on. So now a very basic idea that we get is that what our code will look like. It will have 4 for loops, and each for loop is going to handle one side of the rectangle. So this is going to handle the top one, that is when we are going right. Then the next way is going to handle the downward direction traversal. Then we have towards the left, and then we have upwards. So let's see how this can be done. Okay. So this is the base case. We'll get back to this later. Let's first see how these 4 for loops are working. So first, now over here, now see the rectangle that the first recursive call has to handle is the outermost. So in this, it starts from this column and ends up till this column, and the rows start from the 0th row and ends up till the last row. So first we have to print the numbers from C1 to C2. So first we have to print for the row R1, and over here we are going to have all the numbers from C1 to C2. So see, over here we are printing the numbers from C1 to C2, and we are printing it for the row 1. So this is handling how we are going to go towards the right. Now we have to handle when we are going in the downward direction. Now see, when we are going in the downward direction, we have to start from the next row, that is from R1 plus 1. And we have to go up till the last row, and the numbers that will be printed are from the C2 column. So what we are doing over here is we are starting from the next row, that is R1 plus 1, and we are going up till R2, and we are printing the numbers for the C2 column. Now just ignore this condition just for a second. I'll just show you that why this condition has been put over here. Now let's see for the third for loop. In the third for loop, we have to manage going towards the left. So over here we are starting from a row just before the C2, that is C2 minus 1, we have to go till over here and we have to print the numbers for the row R2. So over here we are going from C2 minus 1. We are going up till 1 greater than C1. You can go up till C1 as well. Only in the next iteration, a little thing will be changed then. I'll tell you what it is. So over here I am going up to this element from 31 to we are going to 29 and we are printing all the numbers in the last row, which is R2. Now in the next iteration we have to take care about these numbers. So what we are going to do is we are going to go from R2 to R1 plus 1, which is a number just greater than R1, and we have to print the numbers for the column C1. So we are printing the numbers for the column C1. We are starting from R2 and we are going up till a number just greater than R1. Now see, if we would have put an equals to sign over here, so this would have been taken care while going left. So this number would have been printed when we are going left. So if over here you put an equals to sign, so over here you will have to put R2 minus 1. Because if this number is being taken care while going towards the left, so for the upward direction, for this direction, we will simply start from R2 minus 1 and we'll end up at R1 plus 1. Now see, after this iteration, what we see is that initially we started from column 1 to column 2 and row 1 to row 2. Now in the next iteration, the rectangle that we have to take care about is this. So in the next iteration, our column 1 will point over here, column 2 is going to point over here, row 1 is going to point over here and row 2 is going to point over here, which is we are incrementing column 1, we are decrementing column 2 by 1 and we are incrementing the row 1 by 1 and we are decrementing the row 2 by 1. So over here we increment R1, then we decrement R2, we increment C1 and we decrement C2. And we again call this so that this gets printed. Now in the third iteration, what we see over here is that we have to print this. Now over here, C1 will be over here, C2 will be over here, R1 will be over here and R2 will be over here itself. So over here R1 and R2 are at the same row. So what we see over here is that over here we just have to care about going towards the right. So what we do over here is, first we are going to have this loop which is handling this situation. We start from C1, we will go up to C2 and we are going to print all the numbers that are in row 1. So 27 to 24, all the numbers are being printed. Now when we have to see for the downward direction, we start from R1 plus 1. So R1 plus 1 becomes 3 and R2 is 2. Now see, the condition falls over here itself. So we do not enter the downwards loop. Now when we go for the left, now see, if this condition wasn't here, so what would have happened? So C2 minus 1 would be 3 and C1 would be 2. So the condition turns true and then we would have been printing all the numbers in R2. So in R2, we would have printed all these numbers again. So this would have been a wrong thing. So what we did over here is we are going to check that if it is not if it is just a single line of numbers, we are not going to have the leftward and the upward for loop. We are going to have these two loops only when it is not a single line of numbers, that is it should have at least 2 rows. So this is how we see. Now see, over here we saw it, but we could have also have an example when we just had one column left instead of one row. So what could have been the situation? We would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So in the first iteration, we are going to manage these. Now in the next iteration, C1, C2 would have been on the same column and R1, R2 would have been on different rows. So even in this condition, we don't have to care about going towards the left and going upwards, as this can be handled only by going towards the right and going downwards. So this is why we have this scenario, that if and only if our R1 and R2 are not same, that is R1 is less than R2 and C1 is less than C2, this is the only scenario when we are going to have our the leftward and the upward for loop, and apart from this we won't have these for loops running. So this is how we can print the matrix in a spiral order. Now let's talk about the time complexity and the space complexity. Now over here we know that we are traversing every number just once. So the time that this is going to take is of order of m into n, where m and n are the dimensions of the matrix. Or you can also say it is order of n, where n is the number of elements in the matrix. Now secondly, if we talk about the space complexity, so no auxiliary space has been taken, see, no extra space has been taken, but it will surely take the space for the recursive calls. So approximately a linear space will be taken for all the recursive calls. Now if we talk about the base condition, so what this says over here is, if my R1 is greater than R2 or my C1 is greater than C2, which simply means is, see every time we are incrementing C2 and we are incrementing C1 and we are decrementing C2. Now suppose after this scenario only, when we increment our R1, so this comes over here to 3, and we decrement our R2, so it comes over to 1. So now over here we can see that our whole matrix has already been printed, so we don't have to print it again. So we just put a check over here that if this is a scenario, we are going to simply return. And the another condition is that if it is not necessary that you use this condition in the recursive call. You can have this condition before you are calling it recursively, because this is just to see that if there are no rows only available, so nothing will be printed. So also another point that you can see over here is, this is a tail recursive function. So what a tail recursive function is, that in a tail recursive function, after our recursive call, there is no other call that has been made. So see, over here my recursive call is on this line, and after this line nothing is happening. So what a benefit of tail recursive function is, we can simply convert our tail recursive function into an iterative function. Now let's see how we can do that. Now see, what is actually happening over here is that this recursive function is only handling the adjustments in the variables and nothing else. So what we can do is, we can simply put this base condition in a while loop and replace the recursive call with updation of the numbers. So see, I have simply taken all this code and put it in a while loop. The conditions will be these. Now see, over here this was a terminating condition, but over here I have just put its reverse, so that these becomes the condition that for the time these are true, this is going to work. Over here it was a terminating condition, over here it is a condition because of which it is working, and I have simply replaced the recursive call by the updation of the variables. Now over here the time complexity remains the same. Over here we have time complexity of n into m, that is for the dimensions of the matrix, and order of n, that is for the number of elements. But over here the stack space is not used, as it is not a recursive call. So over here we can say that my space uses order of 1 when we are considering stack space. Also, we have not used any other extra space, so auxiliary space used is also order of 1. So this was how you can print, or you can traverse a matrix in a spiral order. Now if you like my video, then do hit that like button, share it across with your friends, and that was all for today's video. Thank you.